that, when we're talking about functions in general, what is interesting about functions is the domain of the function, the range of the function, and also the graph of the function. Okay. So recall that if y equals to f of x is a function in one variable, then the graph of the function is defined as the set of points in the plane, the set of all x, comma, f of x or y values such that x is in the domain of f. This is a graph in the plane or two dimension. If I add a new variable and define a function in two variables, I'm actually using all of those triples to visualize the function. Now, for z equals to f of x and y, a function in two variables, the graph is defined this way. The graph is the set of all x, y, and z, or the last component, the output, or f of x and y, such that with the condition that you are taking the first two elements from the domain, such that x and y is in the domain of function f. This graph is in the space, in 3 dimensions. In the space or 3D. So when we are talking about these types of functions, we actually have this visualization. It's going to be in the space in 3 dimensions. So suppose you have your space, x-axis, you have your y-axis, then you have your z, and then you have your surface. This is the surface that you have. This is actually the set of all of x, y, and z values, for x, y, and f of x, y, such that x and y is in the domain of function f. This is called a surface. A surface in the space. So I expect you to ask, what if my z is equal to 0? What if I look at the projection of this surface in xy plane? Of course you can do that. It helps us to understand the behavior of this surface a little bit better. So we can project this surface in xy plane by setting the last component, or z, equal to 0. If z is equal to 0, then you have the projection here in the plane. This is equal to x, y, and 0. Your z is equal to 0, such that x and y is in the domain of F. So the projection of your surface in the plane by setting z or the last component equal to 0. Well, another method or another way to actually analyze graphs of functions is actually using level curves. What is the definition of level curves? And how do we find level curves of a function? So suppose you have a function in 2 free variables. Definition of level curves. Let f of x and y be a function in 2 free variables. The level curves of f of x and y are curves f of x and y equals to a fixed number like k. So let's write down k with a different color. K is a number. So what are we actually doing? We are setting our z value, our output value equals to a fixed number, and we try to visualize the curves of this function by setting it equals to a fixed number like k. So suppose you have a surface like a mountain. Suppose this is your surface. This is your z equals to f of x and y. When you set z equals to k, some fixed numbers, you're actually fixing the height of this mountain. So, for example, this is your k here. You're actually finding this curve. If k is a different number, let's call it k sub 1, and change it to k sub 2, you get another level curve. You're fixing the height, and then you're finding another curve on this surface. These are called level curves of the function. These actually help us to analyze the function when we don't have actual graph of the function. So what are we doing? You're actually cutting the surface by some planes. So suppose you have this surface here, and then you're saying that, hey, what if I cut this surface by some planes? The first plane is this one. Just any plane. When you cut this surface by this plane, it means that your z value is fixed. The height is fixed. So the intersection between this plane and this surface is actually a slice, which is a curve. What is that curve? That curve is going to be this one here. A slice of the planes and your surface. The equation of this plane is slice is f of x and y equals to fixed z value or k, because this is just, you can change these k values and just find another slice, the intersection between the function and the plane. Here another one, get some slices. So another interpretation when we are talking about level curves. These are level curves. These are just curves at specific heights. Example. Well, in this example, we have function f of x and y, which is defined as 6 minus x minus 3x minus 2y. So change these. And question says find level curves when k values are given as minus 6, we have 0, we have 6, and we have 12. So what are we trying to do? We're trying to analyze this graph by looking at the level curves. What are the curves that when you slice some planes with the graph of this function, when k is fixed, negative 6, 0, 6, and 12. So step 1, set function f of x and y equals to k. So what is the first k? The first k is equal to negative 6. 6 minus 3x minus 2y equals to minus 6. Our k is equal to minus 6. Step 2, graph it. Graph this curve. Well, okay, this is just equation of a line. 6, let's write it here. We have 12 equals to 3x plus 2y, which is a line. Okay, so we're going to graph this guy first. X-axis, y-axis. So what are we doing? We're looking at these curves in xy plane. Remember that we are getting rid of our z values. We're assuming that, hey, our z values are some fixed numbers. We're looking at the projection of our surface in xy plane, and we try to analyze and interpret the results. Very well. So here we have this guy here, and here we have this. This is 6, and this is 4. Well, let us connect these 2 points. This is a line. Which line? 3x plus 2y equals to 12. So we're done with the first k. Let us set k equals to 0. K is equal to 0. What do we have? We have 6 minus 3x minus 2y equal to 0. See with different colors so you know what's going on here. Negative 6. Now we're moving on to 0. Okay, you have another one. Graph this curve. This is just a line. So we have 3x plus 2y equals to 6. We have a 3 here. and we have a 2. Okay, so let's connect these two. We get a line parallel to our first line. This is 3x plus 2y equals to 6. So these are level curves. If you continue plug in the rest of the k values, k equals to 6, then k equals to 12, you're going to see that you have these parallel lines lined up next to each other. This is 3x plus 2y equal to 0. Then you get 3x plus 2y equals to negative 6, and so on. These are the level curves for this function, or if you look at the projection of this function in xy plane for specific z values, these are the lines representing those projections. These are some of the level curves. So let us take a look at this surface in the space. So this is your surface, 6 minus 3x minus 2y. This is your surface. We are cutting this surface by some lines. Those level curves are just some lines. It gives us projection in xy plane, and as you saw on the board, those are just some lines. We can use online graphers to actually see different level curves. For example, suppose you have this function or any other function. Here you have, for example, our function that we had, 6 minus 3x minus 2y, and we are trying to find the level curves for our function that we just graphed. So as you can see, if you plug in different values for your k, in this case, in this program, is denoted by c. So suppose I plug in 0. You can plug in different values. You can plug in negative 12 here. You get level curves. As you can see, these lines on xy plane representing the level curves of the plane that you had. So this is your plane, and these are the level curves, the projection in xy plane for specific values of z. Okay, next example for you. Suppose you have your function f of x and y equals to, let's call it g, square root of 9 minus x squared minus y squared. Find the level curves when k is equal to 0. Your z values are fixed when k is equal to 1, 2, and 3. And I have a question for you. What is the general formula for the level curves of this function? Question. what is the general formula for the level curves. What do I mean by that? It means that suppose K doesn't have these numbers. What if K is just a fixed number like K? How do we find the formula for the level curves? Perfect. So what do we have here? We have different values for our K, and we have our function. Remember the steps. Step 1, we set the definition of function equals to K. So we have g of x and y equals to K. What is our first K? Our first K is equal to 0. So when K is equal to 0, it means that square root of 9 minus x squared minus y squared must be 0. But we have to simplify this. We can raise both sides to the second power, and we get 9 minus x squared minus y squared equal to 0, or x squared plus y squared equals to 9. What is this guy? This is just a circle. Circle with center at 0 and radius 3. Okay, perfect. Easy to graph. X-axis, y-axis. 1, 2, 3. 1, 2, 3. Here we go. So this is my first circle as the first level curve. Well, what if K is equal to 1? Let's see what is the next one. K is equal to 1. So this is our step 2, graphing that. K is equal to 1. It means that I need to set the definition of function equals to my K. So I have square root of 9 minus x squared minus y squared. My z is equal to 1 right now. So it means that if I raise both sides to the second power, I get 9 minus x squared minus y squared equals to 1. Okay, let's do a little bit of algebra. Let's rearrange these. We get x squared plus y squared equals to 9 minus 1, which is 8. Well, my radius is shrinking. It means that here I have square root of 8. 2 by something. This is the second circle. It's getting smaller and smaller. We can plug in more values for K, and we actually see that if we set this guy equals to 3, if K is equal to 3, the square root of 9 minus x squared minus y squared is equal to 3, or 9 minus x squared minus y squared is equal to 9, or x squared plus y squared is equal to 0, or the origin. So suppose this is just, let's get rid of this scaling. It's going to show you how you can shrink these. Now this is the last inner circle, and then the origin. So these are the level curves. When K is equal to 0, K is equal to 1, K is equal to 2, and K is equal to 3. These are level curves. There you go. What is the general formula? What if I don't have these numbers here? How do I represent the formula for the level curves? So in this case, I set the function g of x and y equals to k. K is just a fixed number. I don't know what it is. I only know it is just a number. So square root of 9 minus x squared minus y squared is equal to k, or 9 minus x squared minus y squared equals to k squared, or x squared plus y squared must be equals to 9 minus k squared. Remember that this guy is equal to r squared. radius squared. So r is equal to square root of 9 minus k squared. 9 minus k squared must be greater than equal to 0. Otherwise, you cannot solve this. So you need to have this condition when you write the general formula for your level curves. So this is our surface in the space, square root of 9 minus x squared minus y squared. As you can see, it's the upper hemisphere because it doesn't have plus minus sign. It only is square root of. The sign before square root is plus. So that's why you only have the upper hemisphere, okay? The upper hemisphere. Now let us take a look at slicing. So if you think about it, if you slice this hemisphere with some planes that are parallel to, they're just parallel to xy plane, level curves are just circles, concentric circles. Let us take a look at our wolfram. So here we have square root of 9 minus x squared minus y squared. And k is equal to 0. You can plug in values for our k. Let's plug in 1 as well. As you can see, you have concentric circles. You're slicing this graph, and then you get these level curves. So if you visualize this, let me erase this part. If you visualize the surface here, this is your surface in xy plane. X, y, and z in the space. So here you have your surface. Just gonna make more space for this. This is our surface. Upper hemisphere. Okay. So what are we doing? We are slicing this guy using some planes. What planes? Z equal to, for example, 3. When z is equal to 3, you have, suppose you have this surface. Let's use z equals to 3. Just going to be a little bit further up. Much up. So this is going to be your z equals to 3. That's why you get your origin here. Then if z is equal to 2, you get another plane. This is your next plane. And the level curve that you get is going to be in xy plane. This level curve is just a circle. If z is equal to 1, you get another plane. This is what you learned in elementary calculus. These are equations of planes. And then the intersection between this plane and the surface is going to be another circle. And then the projection xy plane are those circles. This is an xy, so this is your x, and this is your y. And these are your circles, concentric circles.